Good morning, everybody. Welcome to a winter Tuesday morning. Well, it's not snowy, it's just cold outside. Of Chem 1211 with your host, me, Dr. White. Almost said the wrong course. But anyways, it's 1211. That's the course, not the time. Uh-oh, it's awful humor Tuesday. All right, let's go through some important announcements. One, remember, all labs under the amnesty program are due by the end of tomorrow, Wednesday, the 7th. Also, the extra credit project, the deadline, remember, it's optional and it's 10 points is due. The deadline is tomorrow evening, end of the day on the 7th. Remember, the extra credit is optional, but 10 points always helps. All right, now let's talk about some important things. Let me get my screen share thing. All right, let's go through this again. This week, and I'd highly recommend you wait until Thursday or Friday. Here's what I want. You should be taking test number 2 at the Glen Ellen, COD Glen Ellen Testing Center. If you don't take test 2 by the end of Saturday, the testing center closes at 2 p.m. If you need time to take the test, you better get there by noon at the latest. And you'll be given 2 hours to take test number 2, but it should take only about 60 minutes or so. You'll need a picture ID, bring your calculator, and obviously I would highly recommend bring a pencil or two. Test number 2 will cover all the material this semester. It has 27 problems on 12 pages, 5 multiple choice, and some of the questions are multiple part. And here's the point breakdown, how it cover the material covered in test number 2. And as I said, I highly recommend you use your test number 1 and quizzes 1 through 6 as practice problems. Are they going to be the same problems? No. Are they going to be similar? Of course. All right, next, I'll put out an email, but I'd like to talk about next week, the ACS final. And the ACS final is a time multiple choice final that you have to take at the COD testing center. You'll have from next Monday until next Wednesday to take it. It's 60 questions. You'll be given 55 minutes unless you're a special needs student. Special needs students who have the accommodation of double time get double time. Now, first of all, unlike what I did, the ACS does not give you important information formulas. So what I'd highly recommend is look at the final exam important information. You will not be given that when you take it, but memorize the important formulas, like 1 mole equals Avogadro's number of atoms or compounds, molecules. 1 mole equals the atomic weight of an element. 1 mole equals the molecular weight of a molecule, and the molecular weight of a molecule is the sum of all atomic weights. Also, you should memorize for the ACS, not mine, test 2, because I'll give it to you, things like Boyle's law, P1V1 equal P2V2, the ideal gas law, PV equal nRT, and also what molarity is and how to calculate molarity. Also, the 3-step problem I have for using the coefficients of a balanced chemical equation to give you molar ratios to use in problems. Now, I would highly recommend when you take the ACS test, do all the non-calculating problems first. You can get those done quicker, and then do the calculating ones. So do the non-calculating, then the calculating. The other thing I'd recommend, which I usually don't, which is why I don't like multiple choice, and I rarely use it, only a couple, is that if you don't know an answer, guess. I don't like doing that, but for the ACS, that's good advice. Because unlike tests, I took a test where if you put down a wrong answer, you were also penalized. The ACS is not like this. So don't leave anything blank. Also, bring a good eraser. So next Monday through Wednesday, you'll take the ACS test. Sometime Thursday, I will get the scores for the ACS, the raw scores from the full-time faculty member who will grade it. It's a Scantron. You just put it through a Scantron reader. It's simple, it's quick. But I won't get that until sometimes Thursday. By the way, Anna, this Saturday, yes, the testing center is open. Let me show you.
No, I meant next week for the final from this ACS thing.
No, because you got to take it Monday through Wednesday.
Okay.
Let's do this. See the calendar?
Mm-hmm.
You'll have for the ACS December 12th, 13th, and 14th. So one of those 3 days, you have to take the ACS final. My test 2, you'll have until the end of Saturday, the 10th. So is that clear now? I guess it is. All right. So also, don't forget, if you need any help, tonight I'll have my office hours and also tomorrow night. Now, there's a strange thing going on with Zoom, and I might have to reissue my office hour. I'll send out an email, an announcement if I have to do that with the new link for that Zoom office hour. Tomorrow is the last day for this meeting set up on Zoom, even though I tried to extend it. They've changed something on Zoom. Oh, I forgot to do that, Gian. I'll tell you what. What I'll do is tomorrow, Wednesday, I will do grade calculations. See, gotta post it. It'll go on my mirror in my bathroom so I don't forget. Yesterday was a real busy day for me. So send me, I will do tomorrow morning, first thing in the morning of the lecture, how many points you need on test 2 to get it. Hold on a second. I don't want to rush it because I can make a mistake. All right. Any other questions before I move on? All right. Yesterday, we were finishing up test number 1 review. And the last thing I needed to talk about will be limiting reactants. And that's the number of moles produced using each reactant. You do that calculation, and then the lower number is the answer. Again, limiting reactants, you'll always be given a balanced chemical equation, and you use the molar ratios. Say you have 5 moles of X and 10 moles of Y. How many moles of C will you make? Well, you take 10 moles of X and see how many moles of C you'll make. Take the number of moles of Y, how many moles of C, and the lower number is the answer. Now, my special holiday gift to all of you, happy holidays coming up for those of you who celebrate Christmas. Have a Merry Christmas. For those of you who celebrate Hanukkah, have a happy Hanukkah. And it's really Hanukkah pronounced, not Hanukkah, but I'll do the English pronunciation. And my special gift to you on test 2, there will be no limiting reagents or reactants, no limiting reactants problems. That's my gift to you. Thank you, Dr. White. You're welcome. Let's do something. All right, let's move on. All right, next I talked about gases. And you should know, which there's a mistake here. It's not that for a gas, pressure 1 millimeter mercury equal 1 torr, 760 millimeters of mercury equals 760. Well, this should be torr equal 1 atmosphere. In gas calculations, if you have to use temperature, it has to be in Kelvin. And Kelvin is degrees C plus 273, converting from Celsius to Kelvin. Now, I taught you Boyle's law, and Boyle's law was P1 equal V1 equal P2 equal V2. And P1 is the initial pressure, V1 is the initial volume, P2 is the final pressure, V2 is the final volume. How do you know when to use Boyle's law? If you're given a problem, and I've taught you how to find out what are you being asked to find, what are you given? If you're given a gas problem and it only has pressure and volume, if you're given a gas problem and it only has pressure and volume, and one of the things pressure volume changes and the other you're trying to find, in other words, you're always going to be given P1 and V1, and then you'll either be given P2 and calculate for V2, or find given V2, calculate P2. Remember, to get rid of something, you divide it, and you have to do both sides. And we went through that. And you can go ahead and look at the problem set for problems on this. Next, the ideal gas law, PV equal nRT. Remember, P is pressure in atmospheres, V is volume in liters, N is moles, T is temperature, not in Celsius, but in Kelvin. And for this class, the universal gas law constant. Now, sorry about that. 3 more. 2 more. 1 more. Stop. Now stop. Thank you. All right. For some reason, maybe it's the holidays, I'm getting a lot of junk calls. But anyways, ideal gas law, PV equal nRT. And the common mistake students make is they don't convert the units for pressure, volume, moles, temperature into the correct units.
Will you give us this formula or no?
I will, ACS will not. Let's see. All right. Now, let's look at, let me do one thing. Get this out. All right. Let everybody see problem 10 on the board on your screen? Yep. Thank you, Gianna W. All right. There's one thing missing from this problem. If you look at quiz 3, 15 points. 15 points. If you burp 86.75 grams of carbon dioxide, CO2 gas at 545 millimeters of mercury at 34.6 degrees C, what's the volume of your burp? Bet you never thought you'd get into burps in chemistry. Well, it is. All right. V is volume. That's what you're trying to find. You're dealing with a gas. You're given the weight, you're given the pressure, you're given the temperature. I also give you R, the universal gas law constant. Why do you need that? Because if you look at this, you're not changing any variable. Nothing is changing. All you're being asked to is find a variable of a gas, in this case, volume. And that plus the 15 points tell you should use PV equal nRT. We want to solve for V. We want it alone on one side. How do you do that? Well, you divide, to get rid of pressure, you divide by it. Anything divided by itself is the number one. And whatever you do to one side, you do to the other. P over P is 1 times V is V is equal to nRT over P. Now, the pressure you're given in millimeters of mercury, you have to convert to atmospheres. And again, you use your good buddy, your good friend, unit analysis. This is what we're trying to start with. This is what we're going to. Atmospheres goes on top, millimeters of mercury go on bottom. If you look at important information for test 2, or I have it listed as the final, you'll see 1 atmosphere equals 760 millimeters of mercury. These are exact numbers. So this is 3 significant figures. Next, temperature is in degrees C. You want to do it in Kelvin, K. Kelvin equals degrees C plus 273. Here's degrees C, add it to 273. This is a number in Kelvin. Finally, moles, it's in grams. You want to get to moles of CO2 because N is moles, and therefore, whatever I'm trying to get to goes on top of this ratio. Whatever I'm trying to get rid of goes underneath. Remember, 1 mole equals the molecular weight of a compound. And the molecular weight of carbon dioxide, 1 carbon, 2 oxygens. You get the atomic weight from the periodic table. And the 3 significant figures for carbon is 12.0, for oxygen 16.0. 1 times 12.0 is 12.0. 2 times 16.0 is 32.0. Added together, you get 44.0. And you convert this to this. Remember, the 1 is an exact number. This is 3. This is 4. You get the same number of significant figures in the answer as the number with the lowest significant figures, 3. And now you put N, we just calculated. We're using this formula. R, you're given. Temperature in Kelvin right here, and pressure is right here. And here you have it in liters. Now, one thing, ACS likes to play games. And the game they might play is, instead of putting A, B, C in liters, they may have milliliters. And you should know 1 liter equals, and I haven't done this semester, because I don't play games like that. 1 liter, not for my test tube, but for the ACS. You should know this. Therefore, if you have 5.21 liters, how many milliliters is that? Well, use your good buddy, your good friend, unit analysis. Whatever I'm trying to get to goes on top. Whatever I'm trying to get rid of goes underneath. And 1 liter, based on this definition, is 1,000 milliliters. Both of these are exact numbers because it's a definition. And now, if I pick up my calculator, which I will, turn it on, clear it. And my calculator gives me the following number. So that's a game that the ACS might play. I don't know, but it's something I haven't done this semester, but you should be aware of that for the ACS. And that's one of the reasons why I made the ACS so small and why I have extra credit on my quizzes and my tests. It's my way of neutralizing the ACS final for you. All right, now on quiz 3, we talked about Dalton's law of partial pressures, and the total pressure is equal to the sum of the partial pressures, P1, P2, P3. So if you have a gas, a mixture, you can calculate the total pressure, which is the sum of all partial pressures, or you can calculate a partial pressure dealing with this equation, solving for, say, P1, given, say, P2 and P3. And that's in the problem set. Now, you should know that what is boiling? Boiling is when the vapor pressure from a liquid, the gas coming out from a liquid, is equal to the atmospheric pressure that's all around us. And at that temperature, that's the boiling point at that condition. Now, when you go higher altitude on our planet Earth, I don't think anybody here is going to Mars or Venus, so I'll stick with Earth, the lower the atmospheric pressure. And the lower the atmospheric pressure causes the boiling point of a liquid to be lower. And you should be aware of that. And this stuff I gave you, just to remind you, these are things you should know. All right, let's move on to solutions. And you should see quiz 4 solutions. Now, a couple of things. First of all, what's a solvent? That's the component of a solution present in the greatest amount. What is a solute? Those are all the others components. A colloidal dispersion, that's not a true solution. Those are particles suspended in a liquid. Now, I had it as a question, multiple choice. I don't know if the ACS does, but I would put it down if I were them. Remember, colloidal dispersion is not a solution. You can tell that because the particles that are dispersed scatter light. Solution does not. Now, like dissolves like is an important concept. Like solutes are soluble in like solvents. Polar solutes are soluble in polar solvents. Nonpolar solutes are soluble in nonpolar solvents. And water, alcohol, and salts are polar. Vegetable oil, gasoline, Vaseline, baby oil, grease, and dirt are nonpolar. And when you take my Chem 1212 organic here, or when I teach it at Elgin Community College, Chem 170, I use like dissolve like to teach you how soap works to get you clean. All right, now some definitions that they can ask you, like I did in my multiple choice. The solubility of a solute, that's the maximum amount of solute that will dissolve in a given amount of solvent. And there are different types of solutions, and a saturated solution contains the maximum amount of solute that can be dissolved under those conditions at which the solution exists. You can't put one more molecule or it'll precipitate to the bottom. You'll see a solid. Dilute solution is a solution that contains a small amount of solute relative to the amount that could dissolve. Concentrated solution contains a large amount. You're not at saturated, but you've got a large amount of solute dissolved relative to the amount that could dissolve. And aqueous solution is a solution in which the water is the solvent. It's abbreviated by AQ. Now, important thing. Oh, I see a question that I missed. All right, Gianna just asked a while ago and I missed. I do not have practice problems for test 2. What I do tell you is use your quizzes 1 through 6 and test number 1 as your practice problems. Those are the type of problems you'll see on my test number 2, and those are most of the problems you'll see on the ACS final. Does that help? Thank you, Gina. Jay. All right. Now, molarity, remember, when you see a capital M, that's moles of solute per 1 liter solution. 1 liter is 1,000 milliliters, so it's moles of solute per moles per 1,000 milliliters. And how do you calculate molarity? Is if you're trying to make a molar solution, how many grams of this do you have to make so many milliliters of a certain molar solution? You need 2 steps. Step 1, milliliters to moles. Step 2, moles to grams. So if you see on your screen right now, what does 1.34 capital M HCl mean? That means there's 1.34 moles of hydrochloric acid, HCl, per 1 liter or 1,000 milliliters. What does 4.56 times 10 to the third capital M NaCl bracket AQ close bracket mean? And what is the solvent? And here we have capital M molarity. So there's 4.56 times 10 to the third moles of sodium chloride per 1,000 milliliters. And the solvent is H2O. water. And that's what AQ in the bracket means. Now, if you see on a balanced chemical equation, the letter after S or G or L, S is solid, L is liquid, G is gas. Just ignore it on the ACS. I don't use those ever. All right, let's look at number 8. How many moles of sodium chloride are in 125 milliliters of a 3.45 capital M NaCl solution? And how do you do that? Well, you say, what am I trying to find? How many moles of sodium chloride? And that's why I have question mark NaCl. What are you given? 125 milliliters of solution and this 3.45 capital M NaCl. So what does that mean? Well, it means M is molarity, 3.45 moles of sodium chloride per 1,000 milliliters. We have 125 milliliters. We want to get the moles of sodium chloride, and I haven't done it all morning yet. So it's time to use your good buddy, your good friend, unit analysis. And it has been mine for many, many, many decades. Yep, decades. And whatever you're trying to get to goes on top of the ratio. Whatever you're trying to get rid of, the units go underneath. And where do you get a relationship of moles of sodium chloride to milliliters? From the molarity. Put that in there. Remember, 1,000 is an exact number, 3, exact number 3. And I have some other examples here. I highly recommend you either look at your quiz, was it quiz 3? No, this is quiz 4, or this problem set. Look at the problem sets. Now, let's look at 11. And let's look at 11. How many grams of sodium chloride are needed to make, that was a holiday gift you just got. How many grams of sodium chloride are needed to make 345 milliliters of a 6.789 capital M NaCl solution? We have milliliters. We're trying to get the grams of sodium chloride, and we're given molarity. There is no way in one step you can go using unit analysis from milliliters to grams. You can't. So you need 2 steps. The first step is going milliliters to moles. We have 345 milliliters. We want to go to moles of sodium chloride. Use your good buddy, your good friend, unit analysis. Whatever I'm trying to get to goes on top of the ratio. Whatever I'm trying to get rid of goes underneath. Where do I get a relationship between moles of sodium chloride and milliliters? From the molarity. 6.789 capital M NaCl means 6.789 moles of sodium chloride per 1,000 milliliters. So I put that in there. Notice milliliters divided by milliliters cancel out. I'm left with moles of sodium chloride, which is what I'm trying to get. And 3, 4, exact number. When you do a multiplication or division, tea break time. No, you don't do a tea break time. You get the same number. Oh, it's real bad humor Tuesday. You get the same number of significant figures in your answer as the number you're multiplying, dividing that has the fewest. So you have 3, 4, and not involved. And therefore, the lowest number is 3. And you get 3 significant figures. Are we done? No. This is moles of sodium chloride. We want to get to grams of sodium chloride. And how do we do that? We start out with moles of sodium chloride. We want to get the grams of sodium chloride. Use your good buddy, your good friend, unit analysis. Whatever I'm trying to get to, the units go on top of a ratio. Whenever I'm trying to get rid of, the units go underneath. And where do you get the relationship between mole of a compound and grams of a compound? Important information, but I'll tell you now. 1 mole of a compound equals the molecular weight of a compound. 1 mole of a compound equals the molecular weight of that compound. And the molecular weight of that compound is the sum of all atomic weights, atomic weight of sodium to 3 significant figures. Remember, the atomic weight is the number underneath the chemical symbol on a periodic table. We've done that numerous times this semester. And for sodium, it's 23.0. The chlorine to 3 significant figures is 35.5 added up. Remember, you get the same number of significant figures to the right of the decimal as the number you're adding that has the fewest significant figures to the right of the decimal. And here, they're both 1, so 1 past the decimal, 58.5, put that in there, 3, the 1 is the exact number, and the answer is 137. Now, I don't know how the ACS does it, and they come up with both ways are always the same, but remember, there are 2 ways of rounding off on my tests or in life. One is each step, and I'm an each step person rounding off, or wait till the end. And I always, for my tests and quizzes a semester, and for test 2 will be the same, I calculate it both ways of rounding off. And if they're different numbers, then both would be correct answers. You know something? Let's do this again. Repetition is good for your grade. So, how many grams of H2SO4, sulfuric acid, are needed to make 345.5 milliliters of a 6.77 times 10 to the minus 2 capital M H2SO4 solution? What are we trying to find? Grams of H2SO4. What are we given? The volume, 345.5, and this saying 6.77 times 10 to the minus 2 capital M H2SO4. As soon as you see capital M, molarity, I always write what it really means, 6.77 times 10 to the minus 2 moles of sulfuric acid per 1,000 milliliters. Now, there's no way I can go from milliliters to grams. Can't. Therefore, you need 2 steps. And those 2 steps are step 1, go milliliters to moles. And here's my milliliters. I want to get to moles. Use your good buddy, your good friend, unit analysis. Whatever I'm trying to get to goes on top of the ratio. Whatever I'm trying to get rid of, milliliters, goes underneath. Where do I get a relationship of moles of H2SO4, sulfuric acid, to milliliters? From the molarity. I put those numbers in, 3, 4, exact number, 3 significant figures. Notice milliliters divided by milliliters cancel out, and you're left with moles. Are we done? No. We need 2 steps because we're trying to get the grams of H2SO4 sulfuric acid. And here we have moles of sulfuric acid. We want to get the grams of sulfuric acid. Whatever you're trying to get to goes on top of the ratio, and you use your good buddy, your good friend, unit analysis. Whatever you're trying to get rid of goes underneath. Where do I get a relationship between moles and grams? 1 mole of a compound equals the molecular weight of that compound. And here, the molecular weight is the sum of all atomic weights. 2 hydrogen, 1 sulfur, 4 oxygen. And each hydrogen has an atomic weight of 1.01. Each sulfur has an atomic weight of 32.0. Each oxygen, 16.0. Multiply them, you get 2.02. 32.0, 64.0. Add them up, and you get 98.02. Remember, when you're doing addition, you get the same number of significant figures to the right of the decimal as the number you're adding up that has the fewest significant figures to the right. First number has 2, next one 1, next one 1. So 0, 2, keep the 0, use the 2 to round off, drop it, and that's 98.0. You put it in here, those moles cancel out moles, do the math, 3, 3, 1 is an exact number, and you get this number, 2.29 grams. And again, and this was just sheer luck, both ways you get the same answer. And I have other examples. Now, I skipped by it, but you should know what are examples of a colloidal dispersion, and that would be latex paint, milk, or your blood. And what are examples of solution? Air, tea, pop, sugar and water, gasoline. And here I have examples of determine which is a solute, which is a solvent. And the solvent is the compound present in the greatest amount, and the other are the solutes. So if we look at 5, lithium chloride is not present. Water is present in the greatest amount, so that's the solvent. Lithium chloride is the solute. Now, water doesn't always have to be the solvent, so be careful. And with that, let's take a 5-minute break, and I'm going to get up and stretch. I'll see you in 5 minutes. I'm back. And by the way, today is Tuesday lab day, but you've done all the labs. Make sure the last two labs that I posted last week when we talked about that you will do and hand in. Remember, you don't have to do anything with your kits, no chemicals. Just use the data in those labs to answer the questions. I'll say that again, slow motion. Remember, the last two labs are due actually today, but by the end of tomorrow, please get it in. And you don't have to do anything with chemicals or measurements. All you have to do is use the data in those labs to answer the questions. And it's 20 points, 10 points each. So make sure you do it. All right, let's continue. And what we just went through was molarity and solutions. So this I can get rid of. That's not what I want. That's what I want. Wait. All right. Hang in there while I open up something. All right. This is quiz 5. And I like to go through this because a lot of you had problems with this. 1, the collision theory. Molecules must collide for a reaction to occur. The minimum energy needed for a reaction to occur when you have a collision is called the activation energy. And for certain molecules, when they collide, they have to have the proper orientation. And for my test tube, you don't have to know this, but for the ACS, you probably do. That's another holiday gift. Now, when we talk about reactions reacting or reagents reacting, they do it at a certain rate. They just all don't go, we're done. And that's called the reaction rate. That's the rate at which products are made or reactants are consumed. And what are important factors that influence the reaction rate? One is physical nature of the reactants. And important thing is it a gas, liquid, or solid? Gases react the fastest. I won't ask that on a test, but the ACS, then liquids and solids are the slowest to react. Again, gases are the fastest, liquids, then solids are the slowest. Now, reactant concentration, how much you have of a reactant. When you increase it, that increases the reaction rate. Next, temperature. Ooh, in red, important. And temperature for most, not all, but most reactions, when you increase the temperature, it goes faster. How faster? Well, there's a rule of thumb. That means rule of thumb means it's mostly true. It's not 100% true, but 99% of the time or so, the rate of a chemical reaction doubles for every 10-degree increase in the reaction rate. Now, another thing that will speed up a reaction is a catalyst. And as I asked on this quiz, How does a catalyst work? It lowers the activation energy. Now, I showed you, and you can go for exothermic and endothermic reactions, the energy diagram, which means I better do it. And this is a quiz a lot of you had problems with. And an exothermic reaction is a reaction where energy is given off. And most of the time, energy is in the form of heat. Now, it could be light, but for the most part, for this class, think of exothermic. When you make something, you also make heat, which is given off. That's why it's on the right. Exo, outside, given off, thermic energy, heat. Like a thermometer measures heat. And the energy diagram, now I use time on the x-axis and the y energy, and it increases going up. Now, sometimes you'll see on the x, maybe on the ACS, they'll have something called reaction coordinates. I use time. At a certain time, A and B have a certain energy. And I'll just arbitrarily put it here. Now, there's a rule, conservation of energy, and the total amount of energy on the reactant side left is equal to the total energy, including heat, on the product side, the right. Well, if you're losing heat, C and D will have less energy than A and B, because A and B have the same amount of energy as C, D, and heat. So if you're losing heat, C and D have less energy than A and B, and for an exothermic reaction, we put it here. And it goes over the hill and down the hill to grandmother's house, we know, to make C and D. And the activation energy is where you start to the top of the hill. And that's called the activation energy, abbreviated E subscript ACT for activation. Again, exothermic reaction gives off heat. Now, sometimes instead of this heat, you may see some number, say X, and you'll see the term joule or joules. This is a measurement of heat. And I didn't talk about that in this semester. I've stayed away from it on purpose. But if they have C plus D and a number and a unit afterward, that's going to be heat joules. So exothermic reaction is a reaction that when you react A and B, it makes C and D plus heat. It gives off. And because of the conservation of energy, the total energy on the right equals the total energy on the left. A and B have a certain energy. On the right is C, D, and heat. Well, if you're losing some of the heat, C and D alone will have less energy than A and B. And this is how you do the energy diagram.
So exothermic is always when we see heat next to it?
For exothermic, it's generally, it will be heat, or it'll be given in the units of heat. I
Okay.
won't have that on my test too, but I'm also doing stuff you might see next week in the ACS. All right, now, the other type of reaction you should be familiar with is an endothermic reaction. And this is a reaction you have to add heat. And here, endothermic, you add heat. And they might have here a number. I won't, but the ACS plus joules, which is a unit of heat. So if you see it on the left side, that means it's endothermic. Endo in, have to add thermic heat, energy. And you should know that endothermic, the heat is on the reactant side, the left side, as opposed to exothermic, where you give off heat, where it's on the right side. And hopefully you all know you're right from left, I hope. Now, what's the energy diagram for this? Again, time, or it could be reaction coordinates on the x-axis, and the y-axis will have energy. And arbitrarily, G and H, I'll assign this amount of energy. Now, the total amount of energy on the left equals the total amount of energy on the right. Now, on the left, it's total energy is heat plus G plus H. Total energy is heat plus G plus H. In this case, if you're adding heat, the energy of G and H is going to be less than the energy of K, J, and K. Why? Because the energy of J and K is the energy of G and H plus the heat. So that means G and H is going to have less energy than J and K, and you make it higher. And the same thing, you have a hill, over the hill and down the hill to grandmother's house we go. And the activation energy is where you start to the top of the nice straight line knot of the hill. And let's go through this again. Endothermic reaction, you have to add heat. And therefore, heat is on the left, the reactant side, plus G and H make J and K. Because the total energy of both sides, left and right, I like those special effects, have to be the same. G and H is going to have less energy than J and K, because on the left, the total energy is GH plus the heat. On the right is J and K. So because you've added heat, G and H alone will have less energy than J and K. Now, next I talk about equilibrium constant. And the equilibrium constant is for a reversible reaction, which I have here, WA plus X moles of B, and the double-headed arrow tells you it's an equilibrium reaction. And you should know, and a lot of you got this wrong on quiz 5, at equilibrium, the forward and reverse reaction rates or rate of reaction are the same. At equilibrium, the forward and reverse rates of reaction are the same. Now, there's an important number called the equilibrium constant. And the equilibrium constant is calculated by the moles of concentration, moles per liter. When you see something in a bracket like HCl or whatever, that means molarity, moles per liter of A, or in this case, of the products, each product to the power. And it's a multiplication, not addition. I could see on the ACS, they'll ask you which equation is right. Instead of times, they'll have plus. That will be wrong. Yes, they play games like that. And each concentration is to the power of the coefficient. In case of C, it's Y moles of C. Therefore, it's concentration of C to Y times the concentration of D to the Z power divided by the reactants, concentration of A to the W power, the concentration of B to the X. Now, the size of the equilibrium constant conveys information of how far completion of reaction 2 has it proceeded. The larger, the greater K equilibrium is greater than 1, the more products are made. If it's less than 1, the less products. So hold on, let me do something I've never done before, but I think I should do now. All right, if we look, let me do this. Let me check here. All right, everybody see problem 5 on the screen? Thank you, Gianna W. All right, here we have write the equilibrium constant for the following reaction. And it's an equilibrium, double-headed arrow. You take the products on the right to the power of the coefficient. So KCl in bracket mean molarity, and the coefficient is 2 times oxygen in bracket, coefficient is 3, divided by the reactant KClO3, that's potassium perchlorate. By the way, this is solid rocket fuel. But and here divided by that concentration, and the number coefficient is 2, so it's second power. Now, one where a lot of you had problems was number 7. For this number, K equilibrium equal 1.0 times 10 to the 20th, which is much, much greater than 1. Part A, describe the relative concentration of phosphorus pentachloride as compared to the relative amount of chlorine gas when equilibrium is reached. Because this is much greater than 1, the products will be much greater than the reactants. And therefore, we have this. Concentration of PCl5 will be much greater than the concentration of Cl2. If this were a negative number times 10 to the minus 5, the opposite would be true. Chlorine would be Cl2 greater than the PCl5. And another one that I put down is describe a key fact about the forward and reverse rate of reactions for this chemical reaction when equilibrium is reached. And as I said earlier, they're the same. And finally, what happens to the rate of a chemical reaction when you increase the temperature by 10 degrees C? it doubles. Now, next, I talked about for quiz 5, Le Chatelier's principle. And this is an area students always have trouble with. So let's go through it. Here we have an equilibrium shifts to the side to reduce the stress put on the equilibrium. And you should know concentration effects and temperature effects for exothermic and endothermic reaction. Now, as I had on my test, and hopefully everybody's seeing this, let's do this equilibrium. And I'm going to do something else. A is red, C is blue. Now, this is an exothermic reaction. How do you know that? Because heat is on the right. Now, let me remind you, when you put something in boiling water, you add heat. You put something in an ice bath, it removes heat. So, question. They might write concentration. I'll do this. What happens to the concentrations of B and D if I add more A? At equilibrium, there was a certain amount of A. And I'm going to stop for a second. So when you're watching this video, you stop it and think about it. And now I'll give you the answer. Hit pause, think, write your answer. And now at equilibrium, there was a certain amount of A. There's too much A. How do you get rid of the excess A? Well, A reacts with B and shifts the equilibrium to the right. This is called shift. I don't use the terminology, but ACS might, shifts it to the right. Now, what happens to the concentration of B? If A reacts with B, B is consumed. When something is consumed, you have less, it will decrease. Now, what will happen to the concentration of B and D when you remove some A? At equilibrium, there was a certain amount of A. And now there's less. It needs more A. How can you make more A? C and D react to make more A and B. And this is called, it shifts the equilibrium, which I don't use, but the ACS, to the left. But when it, C and D react, since D is reacting, when anything reacts, it's consumed, you have less, it will decrease. And now B will be increased because you're making more. You're shifting the equilibrium to the left, so that will increase. And I'm gonna let you try one. What color will the solution be if I put the reaction in boiling water? Your turn. And when you're done, give me a thumbs up. Again, the question for you to answer is, what color will the solution be if I put it in boiling water? Now, on the ACS, they won't have letters, they'll have chemicals, but you should be able to figure that out. Remember, double-headed arrow means equilibrium. Remember, give me a thumbs up when you're done, or give me a thumbs up if you want me to do it right now. Give you another 30 seconds. I'm looking at the clock up here. All right, let's do this. What color? Oh, what did it happen? What color will the solution be? I don't know how I did that, but anyways, hold on one second. Let's see if I can. There we go. What color will the solution be if I put it in boiling water? At equilibrium, there is a certain amount of heat. Boiling water adds heat. Now there's too much heat. How does it get rid of heat? Well, heat reacts with C and D to shift the equilibrium to the left. When it goes to the left, what color is on the left? Red. So the answer will be, it will turn red. And you did that. Well, you had different colors. All right, this is for exothermic. Let's do endothermic. And that means heat is on the left, the reactant side. All right, I'm going to let you try one. What happens to the concentration of H and J and K if I add more J to the reaction? Your turn. You have two choices. It's never going to be, it stays the same. Don't forget, I have office hour tonight from 6 to 7:15. If you need any help, have any questions, always feel free to stop by. All right, my turn. How many people want me to do it? All right, by popular demand, I'll do these. All right, but you should go back, stop the video. When you watch it again, you try it on your own. Now, at equilibrium, there was a certain amount of heat, G, H, J, and K. By adding more J I put the system under stress. Oh no, I have too much J. I have to get rid of some. The only way you can get rid of J is J and K react to make more G, H, and heat. And this shifts the equilibrium, which I won't ask, to the left. And when something reacts, K, because J and K are reacting to get rid of the excess K, it's consumed. When something is consumed, you have less or the amount decreases. Remember, if you have a cookie in your hand and you eat half of it, do you have the same, more, or less? And the answer is less. And since we're shifting this way, we're going to make more G and H. When you make more of something, the amount you have will increase. Now let's do one more. Sometimes I'm thinking ahead of before I write something. That was a case just happened. I was not finishing writing ice, and I was already thinking of the word bath. All right, what color will the reaction be if I put this in an ice bath? And I'll do this one. What does an ice bath do? Oh, look, someone was nice enough to write here, ice bath, removes heat. Therefore, when you put it in an ice bath, you're removing heat at equilibrium. There is a certain amount of heat. By putting it in the ice bath, I'm removing heat. So there's less heat than should be present. So, oh no, I don't have enough heat. How does the reaction make more heat? It shifts to the left. And when it shifts to the left, you're going to make more H, which is yellow. And that's what the color will be. Now, if I look at the clock, I think now would be a good time for me to stop for today. I'll finish up tomorrow. Don't forget, tomorrow I'll have a special surprise for you. I'm going to take you inside a chemical plant via pictures, but I'm going to cut it out of the video. And I'll explain why tomorrow, but I'll cut that out of the video too. And I'll go through the last things and I'll answer any questions. Now, if you like what I did this semester, don't forget to fill out the student evaluation. Also, if you didn't like what I did this semester, I'll also ask you if you really like what I did this semester, please go to ratemyprofessor.com and write something. If you didn't, then don't write something negative. And if you really, really liked what I did, write a letter to Dr. Caputo, president, or email president of COD. If you didn't really, really like what I did, write him a letter too. And with that, I'm done for today. Don't forget, by Saturday, end of Saturday, 2 p.m., you should take test number 2 at the COD testing center. Also, next week, Monday through Wednesday, you should take the ACS, the Chem 1211 American Chemical Society final at the COD testing center. And don't forget, tomorrow is the deadline, if you're planning on it, to do the extra credit, and the labs are also including the amnesty. Well, that's a lot to remember. With that, I'll say, gang gesund, goodbye.